Okay, on Mops 6, you're going to see this chart, and it looks initially pretty overwhelming, but you can actually do it pretty well. Okay, what's going to happen is I'm going to get a pen here, and we're going to go. So what K is equal to is kinetic energy. Okay, you probably ought to write this down. P is going to be equal to potential energy. W is going to be equal to the amount of work being done. Okay, and that is the beginning system. The initial system is what's happening here. Okay, the final system is what's happening here. So kinetic and potential are what the situation is at the beginning, and then this is what the situation is at the end. So here we have a lot of kinetic energy. Okay, we have a lot of kinetic energy. However, there is some negative work being done. And my thought is that that would probably be the force of friction, which is opposing the car going down the thing. And that force of friction is slowly but surely taking away all of the kinetic energy. And we know before that the force of friction is an external force, so it can change the total amount of energy that's in the system. So here, our final position is what's going on here. So here we have all of our potential energy. So in this situation, what's probably happening is not a car slowing down or speeding up, because if that were to happen, the amount of energy in the system would have been zero. What's happened here is something like a ramp, where you have a lot of kinetic energy at the bottom of the ramp. As you're going up the ramp, you're slowing down, so you're losing your kinetic, okay, which is negative work being done by the force of gravity, and you're gaining potential, okay? So that's kind of how you read that chart. So let's go to look at chart B. So on chart B, we have a whole lot of kinetic, not a whole lot of potential energy, and no work being done, okay? So in chart B, somehow this is transferred to the kinetic energy being changed into all potential energy. So what could change kinetic energy into potential energy? Okay, without any work being done. So that kinetic energy has to be automatically transferred to what potential energy is. Okay. Our chart C, what's happening here is you have positive kinetic energy, you have negative work being done, and here you have no energy in the system. So the work has canceled out the kinetic energy. So what's happening here would be similar to what I introduced before, where you could have the force of friction, okay, applying it over a distance to counteract the kinetic energy, all right? And chart D would be the kinetic energy and work being done, and what the kinetic and potential energy would be. If there's kinetic energy and it's positive, and work is also positive, you can actually gain energy in the system. Okay, so that could either mean that you still have all of your kinetic energy and now you also have some positive potential energy in there, or what the system would be. So sometimes what they'll do is they'll give you the initial systems, okay, and you'll have to predict what the final will be, or they'll give you the final systems and you'll have to predict what the initial systems were set up to be. So keep in mind, you're going to be looking for terms of internal forces and external forces and whether they're conserved or not. And if you have any questions, go ahead and ask Ms. Hobbs in class. Thanks.